Hello guys, and welcome to another update about the Masamune project that I'm working on. Last week, I think, or was it 2 weeks ago? I cannot remember. I talked a little bit about the problem that I had with the attributes of the characters in my game. And the last week I did a little bit of a bigger refactoring in that regard, and now it's a lot easier. So before I always distinguished between the character statistics, so the player currently, which has this set of attributes, which was in a so-called statistic component. And then there was also the equipment, so the different items, which are also entities in the entity component system. And they also had this stats component. And I always had to add up the player statistics and the equipment statistics at different locations. I also had this problem that there is an attribute in the game which is called Constitution, which increases the maximum hit points of the player, and also Strength, which is increasing the physical damage when he attacks with the weapon. And those derived attributes, let's call it like that, they were a little bit tricky for me, and I had some duplicated code pieces in my code base to treat with them properly. And that was not very convenient, and also a little bit buggy, because when I changed it at one place, I always had to remember the other places where I need to treat them in a special way. And it was pretty obvious that that was not the best solution. So what I did, I opened up the AI tool of my choice and talked a little bit what it suggested. And actually what it suggested was, in my opinion, a pretty nice idea. So the proposal from the AI was that I should have two components, one base statistic component with attributes which are not derived. So like, I don't know, intelligence in my case, agility, or mana points. And then another component for the derived attributes, which would be in my case the hit points, which are derived from Constitution and the base life, or the damage, for example, which would be derived from the normal base damage plus extra the strength of the player. And then it suggested simply a system like we have it normally in an entity component system. And there would be a derived attribute system which simply updates then the derived attributes to the values that it needs. And I think that could be a very clean solution if you work in a strict entity component pattern. But in my case, what I try to avoid in Masamune, because I had this problem in previous projects, is that certain things, if you really develop in an ECS pattern, that certain things have a delay. And what I mean with that, so imagine you are inside the combat, for example, in the combat system, and the combat starts. And my player has them some attributes like, let's say, a strength of 10, and therefore also a damage of 10. And now if I would have a spell that increases the strength, then in the pure ECS pattern, I can simply write, for example, increase the strength of the player by 10, then he would have 20, but the damage itself, which is derived and gets updated then in this separate system, that one will come at a later point. So after my combat turn, or whatever I'm currently doing in combat, after all of that is processed, then the next system would be, for example, this derived attribute system, and only there the attributes get updated. And that kind of delay is sometimes a little bit tricky and annoying, in my opinion, in a pure ECS pattern. Of course, you can always manually trigger a system at any point in time, but that also, in my opinion, does not really feel clean, that I increase the strength, then I manually run a system to update all the derived attributes to its state, and then run the remaining logic of the combat system, for example. That's why I have a little bit of a mixture in this project. So I have the typical ECS pattern with the systems and everything, but I also have other things that simply update entity stuff immediately without the need of a system. And I'm not 100% sure yet if that is a good or bad solution, but currently it simply works out. And yeah, what I did so far is I could throw away a lot of code, which I always like when I can get rid of certain code pieces. And the other thing now, which was not that difficult, is that I currently just have actually two methods where something is happening with the player and his inventory or his equipment. One method is the equip item or the remove equipment. And the only thing that I need to do is that when I'm removing the item or whatever, then simply from the statistics from the entity where, for example, I equip an item to a specific entity, and then I just get the character statistics. That's this new component of the character attributes. And there I simply add the item statistics, which is the bonus of the item itself. And those two components, they are very similar, but not 100% exactly the same. So what I did, so as mentioned before, I had just one component, the stats. And now I split it up between item stats, which is really, really very simple. Currently, everything is a constant there. I could use a data class. And that's basically all the attributes in the system that I currently have. And an item can increase or decrease one of those attributes. That's it. So there's no logic behind. It's really a very stupid and simple data holder of the attributes of an item. And on the other hand, I have the character statistics, and they are a little bit more tricky, but not super tricky. There's a lot of code, but it's very simple stuff. The character statistics also have most of the all of the statistics that we have seen on the item itself, but its creation is a little bit different because for the hit points and mana points, I decided that you just pass in one value. So you don't pass in a life and a maximum life or mana and maximum mana. You just give it the base life and the base mana. And then when such a component or such a character statistic gets created in the constructor for the attributes which are influencing other attributes, which is currently just constitution, which modifies the maximum life, and strength, which modifies the damage, there I need to set them afterwards because I have, at least that is how I solved it, I have custom setters for the mana maximum, for the strength, for the constitution, and for the maximum life, which basically calculates the derived value automatically. And I also have some logic in the life and mana attribute that is what I mentioned also in the last video. For example, if you have 10 life and 10 maximum life, and your maximum life increases now by another 10, so it goes up to 20, then I personally want that also the hit points, the current life goes up to 20. Or in other words, that the percentage of the current life and maximum life stays the same. That's written down in here. I also made some tests for that it's properly working. But that's basically what I've written here. And there are some exceptional cases if you would have an initial maximum life of 0 for whatever reason, and after that you increase it to some value and things like that. So that's why there are a couple of cases that I cover here. But in the end, this character statistics component, that one has this built-in logic for some derived attributes that I currently support. And it has two methods. I can add item stats to it, which basically increases all the attributes that it needs to do, and a minus assign, which reduces a bonus of an item. And back to the equipment item. So there simply when an item gets equipped, then I need to add the item statistics to the player immediately. And when I remove an equipment, if there was any item equipped, then I need to remove the item statistics from the player. So that's now a way easier solution than what I had before. So the attributes immediately get updated and always reflect the total amount of everything. So the player itself and all its equipment, all of that is immediately reflected in the character statistics of the player. And that made it a lot easier now to handle everything. And as mentioned, I could throw away a lot of custom code that is no longer needed. And yeah, besides equipping and removing equipment, there's also an item consumption, so a consume item method, It would be, for example, if you drink a strength potion, which increases your strength by a certain amount permanently, or what I currently have in place, a mana potion and a life potion, which is simply healing yourself. That's also now very simple. So it's also just the item statistics gets added again to the character statistics. So all of them gets increased. And there is a special case. So if it heals you, so if it heals your life or your mana or replenishes your mana, then there's also a sound effect played. And yeah, that's it. So there was a bigger refactoring, but that solved most of my problems now, or all the problems that I had. And another thing that I did, which was also reflected or related to refactoring, was in the tiled editor, which I always had in mind that I need to refactor that at some point. So before, I just had on the tile set, on the different objects, on the tiles that I add here, where I configure my objects in the game, I only had one class, which was called map object, and that one had a lot of different attributes, like the atlas, where I get the graphic from, the kind of combat actions that an entity can use in combat, the speed, how fast it moves, the statistics that it has, on an NPC, for example, the trigger when you interact with it, what kind of trigger should be triggered at that point. For items, how much it costs, what consumable type it has, so if it can be consumed only in the inventory, only in the combat, or in both, things like that. And that list got pretty big, so it was quite a large list of attributes. And for most of the objects, that was not really necessary. So that's why I split it now up. And I have now, for example, an NPC object class, which only has the relevant configuration for an NPC in the game. Or I have an enemy object, which only has the relevant configuration for an enemy. Same for items, for just generic prop objects like this tree, for example, and the player itself. And yeah, that was also a little bit of work to refactor that, also to rewrite the tests accordingly that they work again. But I think that was necessary and helps in the future, because now when I add a new object, before I always had to go through all the attributes and think, is that important for that specific object, or is it not important? And now it's very easy. So when I create a new NPC, I just add the class, and then I see, okay, assign an atlas, assign the object type that it has, and assign the trigger that should get triggered when you interact with that NPC. Or for an enemy, there I also have, again, the atlas. That's always necessary. What kind of combat actions can it execute? What is the level? What statistics does it have? How many talents, so the money, how much would it give at the end of combat? And how much experience does it give at the end of the combat? So that's also now a very, in my opinion, convenient solution for that. And last but not least, I forgot to give you one little update, which might be interesting to you. In my last tutorial series, I forgot its name, was it called Mystic Woods or something? This little RPG where I just showed different solutions to different problems in that kind of 2D game development. There we worked with behavior trees. And if you remember correctly, during the tutorial, I showed you a solution how you can do that with text files, because GTX AI supports the specific text file format where you can define the behavior of an AI entity in your game. And I think shortly after the tutorial, if I'm not mistaken, in LibKTX, so the Kotlin extensions for libGTX, they also created there an AI module, and there are also now some DSL functions available that you can define those behavior trees in Kotlin code, which has the advantage that, in my opinion, it's more flexible than the text version, but not 100% sure, because I'm not an expert with the text version. But to give an example, so that is currently the default behavior in Masamune. So you have a behavior tree, that's the typical libGTX AI object. which always has a, I think they call it blackboard, which is more like the entity of the behavior tree or the owner of the behavior tree. So when you execute some code, on which object in your game should it be executed? In our case, that would be an entity. And then you just start a new behavior tree with that DSL function here. We assign the object, which is our entity. And then we simply have a so-called selector, which picks one of the things below, if I remember here correctly, and stops at the first one, which is executed successfully. And there I simply have currently 3 sequences, and a sequence also to remember, a sequence aborts if one of its tasks below fails, and otherwise it continues until the end. So the first sequence here, for example, it just generates a random number. And I pass in here, so that's a utility function from my side. I pass in here to which percentage an enemy will use offensive magic. For example, in this case, it would be 20%. So if this random number is greater than this 20%, or I don't know how to say that, but it creates a random number, for example, between 0 and 1. And if it's less than or equal 0.2, then this random task here succeeds. So it goes to the next one, which is checking if the entity has offensive magic. So does it have any offensive spell that it could use? If yes, then it will use this offensive magic. And then this sequence here succeeds. And the selector then is done, let's say. And the behavior tree stepping, so when we step through this tree one time, is then done, and the AI entity will use or cast an offensive spell, and that's it. Otherwise, for example, if the random fails or if the entity has no offensive magic, then it will go to the next sequence, which is basically the same, but for defensive magic. So again, a percentage, should it use it or not? Does it have defensive magic? If yes, then use it. And otherwise, does it have a normal attack? If so, then attack. And the last thing, so if it cannot cast offensive magic, cannot cast defensive magic, and it cannot do a basic attack, then simply do nothing and wait for this turn. And yeah, I think that is, in my opinion, a nicer to write syntax than in this text file that we did it in the tutorial, because here again we have code completion, we have the Kotlin language, so we can write whatever code we need. And yeah, we also can pass in then some information from outside, like in this utility function, and use it within the behavior tree, which is also very convenient. And yeah, not sure if you're interested, but I can quickly show it. So has offensive magic. That's simply a task. I think it's called a leave task in GTX AI. And what it does is simply it gets from my entity, so the AI entity, it gets the combat component. The combat component has a linkage to the magic action, so what kind of spells an entity can use. And in case of the offensive magic, we filter here for any magic that is not defensive, so it must be an offensive magic. And it also checks, can this magic be performed? So can perform action. That one is checking for each of the magic actions which are not defensive. It checks, for example, does the entity have enough mana cost to cast it? In the future, I might add also effects like silence to the game, so that when you are silenced, you cannot cast magic, for example. And that one is all checked and this can perform. So very simple, simply some filtering over a collection of actions, magic actions that are available. And finally, use offensive magic, which is also very similar. So there is a use action method, and there again from the magic actions, it filters again for any spell that is not defensive and which can be performed. And then it just picks a random action from that one, so a random offensive magic, and it will cast it. all of that. So here you see that is part of the libktx documentation. So there's this GTX AI DSL, so that we can use this function here, use offensive magic within the behavior tree DSL. And yeah, so there's a little bit of boilerplate, let's say, whenever we need to add here a new function in this DSL context. But yeah, it's not too difficult, just copy and paste, I would say. And then we can write, in my opinion, a very clean way of defining a behavior tree. And I think, think that's it. Yeah, that's it. So last week was just mainly some refactoring that I've shown before. And now I think I'm good to go again for some additional features that I will work on in the next 1 or 2 weeks. I have some things in mind that I want to do, and will give you an update then when there's something finished again. Thanks for watching and have a nice rest of your Sunday. Bye bye.